So far we've concentrated on linear functions, which are characterized by having a constant rate of change, or a slope. In the last lesson, we looked at exponential growth and decay. In this lesson, we will more formally introduce the concept of an exponential function. So consider this function. F of x equals 8 times 2 to the x function. Answer the following. So evaluate each of them. So if I have 8 times 2 to the second power, because that 2 is telling me it goes in here. Well, 2 to the second power is 4. 8 times 4 is 32. So now to the 0 power, 8 times 2 to the 0 power. Remember that exponent is only affecting the 2. It's not affecting the 8. So this becomes 8 times 1, because anything to the 0 power is 1. So this equals 8. And finally, 8 times 2 to the negative 1 power. Remember, when we have a negative power, it makes it become a fraction. This is the same thing as 8 divided by 2, which is 4. So calculate the average rate of change of f over the interval. So we have change in y over change in x. Well, my change in x from negative 1 to 0 goes up 1. And then the y goes from 4 to 8, which goes up 4, so my average rate of change is 4. But now let's look at the average rate of change over the interval when x is between 0 and 2. So change in y over change in x. So my x goes from 0 to 2, so it goes up 2. But from 0 to 2, it goes from 8 to 32, which is a change in 24. So 24 divided by 2 is now 12. That's a very different rate of change. So what does comparing the answers from B and C tell you about this function? Well, it's not linear. There's not a constant rate of change. So using your calculator, draw a sketch of this function on the axis below using the window indicated. So I'm going to plug in what it looked like on Desmos. When you go to type this in on Desmos, you'll type it in as y equals 8 parenthesis 2, and then you'll do the little AB to get the x as an exponent. And then if you go to the little wrench up in the top right corner, it will give you the options to change how you want the axis to look. You notice on your notes, you want the x to go from negative 4 to 4, and then the y you want to go from negative 10 to 130. So this is how you set it up to make sure you get the right view. Now, as for the graph itself, we're going to sketch one that looks kind of like this. So the negative 4 is not quite at 0, and it's going to cross and just go up from there. So I'm going to put arrows on each end because it keeps going to the left and it keeps going to the right. So exponential functions are all about multiplication. The basic form of an exponential function is given below. So a general exponential function has the form y equals a times b to the x power, where a is the y-intercept and b is the base or multiplying factor. Sometimes b is known as the growth factor. So let's look at the next function. G of x equals 54 times 1/3 to the x power. So evaluate g to the 0 power. So we're going to look at 54 times 1/3 to the 0 power. Anything to the 0 power is 1, so it equals 54. So what this means on the graph of g is that when that the y-intercept is going to be 54. So without the use of your calculator, determine the values of g of 1 and g of 2. So g of 1 is going to be 54 times 1/3 to the first power. So 54 times 1/3. Remember, that's the same thing as 54 divided by 3. So 54 divided by 3 is 18. Now to find g of 2, is 54 times 1/3 to the second power, which becomes 54 times, well, 1 squared is 1, 3 squared is 9. So it's 54 divided by 9, which is 6. Now, using your graphing calculator, sketch a graph of this function using this window. So what I want you to do is I want you to pause now, use the information you learned on the other question to see if you can figure out the window and to make the graph itself. So the first thing it asks you to do is to mark the y-intercept. Well, the y-intercept is at 54. And the graph does this. So why is this exponential function always decreasing while the other one was always increasing? Well, it's decreasing because the fraction has the exponent. The other one was a whole number. This one is a fraction that has the exponent. So, increasing versus decreasing exponentials. The y equals a to the b to the x power will increase if what? If b is more than 1. And it will decrease if b is in between 0 and 1. So for each of the following exponential functions, give its y-intercept and tell whether it's increasing or decreasing. Remember, the y-intercept is that number outside of it. So the y-intercept is 8 and decreasing. Letter B, 125 and increasing. And 56 increasing. The reason why those two are increasing is because they are larger than 1. So for each of the following exponential functions, give its y-intercept. Oh, that's what we just did. So now let's look at the equations of exponential functions. Are relatively easy to determine if you understand this lesson so far. Let's see what you can do in the next exercise. So find the equation of the exponential function given this table. So first of all, what is my y-intercept? Well, the y-intercept is when x equals 0. That's when it crosses the y-axis. So f of x equals 10. That's the number that goes on the outside. Now we need to figure out what's happening each time. So from 10 to 20 is, 10 to 30 is plus 20, 30 to 90 is plus 60, 90 to 270 is plus 180, and 270 to 810 is plus 140, or 540. So what's happening each time? If it's not working, to add each time, because remember, adding is going to be a linear equation, so those don't work. So you have to think about, is it multiplying or dividing? Well, this one is getting larger, so it's multiplying. Remember, they're all multiplying, but multiplying by a whole number or multiplying by a fraction. So multiplying by a whole number. So 10 times what equals 30? 3. 30 times what equals 90? 3. So each time it's multiplying by 3. So it becomes 10 times 3 to the x power.